Number 2. There are 2 sets of balls numbered through 1 through 5 in a bowl. If 2 balls are randomly chosen without replacement, find the probability that the balls have the same number. Okay. So first we want to think about, is this a combination or a permutation? Well, what are they asking us? So what do they want to find the probability of? They want the probability that the 2 balls that they pick out have the same number on it. They don't mention anything about order, right? So I'm going to write out there's 2 sets of balls numbered 1 through 5. So these are all the balls that are in that bowl. We have this first set numbered 1 through 5 and this second set numbered 1 through 5. So there's a total of 10 balls, right? And they're not concerned with picking out a 4 first and then picking out a 2. They don't care. They want to know that we pick out the same number, and really order doesn't matter, right? If we pick out this 4 and then pick out this second 4 by chance, that's pretty much the same as picking out this green 4 followed by the blue 4. It doesn't matter. You're still picking out the same number. So the point I'm trying to make is this is a combination. Order is not going to matter because they just care about the numbers being the same, not the order of those numbers. Okay. So we want the probability that we pick the same number on 2 of the balls. All right, so again, I think the tricky part with these problems is figuring out these values. What's the number on top? What's the number on bottom? So on top, we want the number of ways we can choose the same number, right? That's what we're trying to find the probability of, right? What's the probability that we pick out 2 balls and they have the same number on them? So that's what we want to figure out for the top number. What's the actual number of ways we can do that? And then on the bottom, it's the total number of ways to pick out 2 balls. Doesn't matter what those numbers are. So let's figure this out. In how many ways can we choose the same number? So if we pop back over here to my little picture, I guess you could say, in how many different ways could we pick out the same number? So, there's 2 ones, right? We could pick out a 1, or we could pick out a 2, or we could pick out 2 of the 3s. We could pick out 2 of the 4s. We could pick out 2 of the 5s. I was counting these because how many different ways can we pick 2 of the same number? There's 5 different ways. And basically that's lining up with the number, we have numbers 1 through 5 in the bowl, and there's 2 sets of those. So there's 5 different ways we can pick the same number. We could pick 1s, we could pick 2s, 3s, 4s, or 5s. 5 different ways to pick the same number. So that's what's on top. 5 different ways to pick that same number. And by the way, this is a problem I legit took from your homework. So whatever you see in your homework will be quite similar to how we're doing it here. Okay, now on the bottom, the total number of ways to pick 2 of those balls. So remember, this is a combination. So there was 10 balls total, and then we're choosing 2 of them. So on the bottom, we're going to have 10 choose 2. So once again, I'm going to kind of go to the side. Let's figure out 10 choose 2. So plugging that into the formula, we get 10 factorial over 2 factorial times 10 minus 2 factorial. Let's simplify. we get 10 factorial over 2 factorial times 8 factorial. Now, I'm going to skip a couple steps here. But remember, if I scroll up here, what we did with the 16 choose 3, remember we peeled off numbers until we could cancel out those 13 factorials? Well, here, we want to cancel out the 8 factorials. So I'm going to do 10 times 9, and then the rest would be 8 factorial, right? But that's going to cancel with the 8 factorial on the bottom. So I'm just going to write it like this. 10 times 9 divided by 2 factorial. Again, that's because, I think there's 2 L's in canceled. The 8 factorial on top and the 8 factorial on bottom canceled. And I just kind of skipped that step. But, by all means, pause this, write out that extra step. You'll get the same thing. So we have 10 times 9. 2 factorial is just 2. So we get 90 divided by 2, and that is 45. So our number on the bottom is 45. Our number on top is 5. So you can simplify this. What is that, 1/9? Or plug in a decimal. Make sure you round it to 5 decimal places. And in this case, we just get 0.11111. Okay. Let's do another one. Last but not least, at least for this video, and then we got 3 more problems in the next one. So number 3, we have a committee. Let me fix the cursor. It keeps switching. There we go. A committee of 4 is being formed randomly from a select group of students at a local college. In this group, there are 5 freshmen, 10 sophomores, 12 juniors, and 8 seniors. What is the probability that all 4 members of the committee are juniors? Okay, so you want to figure out the probability that they are juniors. So before we dig into that, is this a combination or a permutation? So they're just talking about selecting people for a committee. They're not talking about president or vice president or treasurer. So order does not matter, once again. So this is a combination problem. So we're going to be using combination formulas. Now we want to focus on the probability that out of this, when they form this committee, it's only juniors. So my top number is the number of ways to pick 4 juniors. Right? That's what we're focusing on. How can we pick 4 juniors? 4, why am I saying 4? Because that's how many members are on that committee. But then on the bottom, it's just the total number of ways to pick 4 people, to pick those 4 students. It doesn't matter if they're juniors, sophomore, freshman, senior, whatever. So on top, we want the number of ways to pick 4 juniors. On the bottom, the number of ways to pick all 4 students. So with the last 2 problems, we were kind of able to figure out that top number just kind of by thinking about it. Like for problem number 1, there's only one way to create a pizza with those 3 specific toppings. For problem number 2, there was 5 different ways to pick out that same number. Well, for this problem, we have 12 juniors, but we only want to choose 4 of them. And order does not matter. So we are going to have to use a combination here. There's 12 juniors, but we're only choosing 4 of them. So my top number is essentially a combination. So every problem is different. You just got to read it and see if you can, figure out that top number easily like we did with the last 2 problems, or sometimes it might be its own combination or its own permutation. And that's usually when we're dealing with a bigger number. Figuring out 1 or 5, A little bit easier than figuring out 12 choose 4, which we'll find out what that is in a minute. The number on the bottom is the number of ways to pick any of these students. So first we have to know how many total students there are. And we could do that by just adding up. We have 5 freshmen plus 10 sophomores plus 12 juniors plus 8 seniors. Add that up, you should get 35. So there's 35 students to pick from, and we want to choose 4 of them. And then we want to simplify this equation right here. So to keep this short, and because we've worked through these formulas before, I'm just going to go ahead and give you the values, and you can see if you end up with the same thing by using the method of your choice, using a picture or just plugging everything into the formula. But what you should get is that top number equates to 495, which means out of those 12 juniors, there's 495 different ways to pick out 4 of them, to choose 4 of them for a committee. And then on the bottom, 35 choose 4. That's a bigger number. It's 52,360. Now, I definitely don't want to try simplifying this fraction, so I'm going to go ahead and just go straight to making this a decimal. 0.00945, and I rounded it to 5 decimal places.